There are so many beautiful 3D printed planters and products being made all over the world. From a quick search on Google, you can see all the variations in design. After seeing all these projects, I was inspired to merge architecture with flower pot designs to create miniature worlds for houseplants. To start, I came up with a quick sketch of my idea using my iPad Pro, Apple Pencil, and an app called Morpholio Trace, which I'll link in the description of this video. The idea was to create an architectural plaza with stairs at 4 corners leading up to a walkway. At the center, there would be a void for soil and plants. At the bottom of the void, there will be 6 small drainage holes so excess water comes out of the bottom of the pot. That means we also need to have a drainage pan to catch excess water. The pan will have stubs that raise the planter off of the surface so that all the excess water can completely drain out of the pot. With the sketch complete, the next step of the design process is to create a 3D model of the project, which we'll send to the 3D printer. Using a software called Rhinoceros, I start by drawing the overall size of the planter. It'll be a 5.5-inch square with a 1/2-inch walkway and a 1/2-inch staircase on all sides. That brings the overall size of this planter to 6.5 inches square. I won't go over all the steps in the software for designing this project, but if you want to learn, check out some tutorials here on YouTube or on Skillshare to get started. After I drew the general shapes of this project, I outlined the shape of the staircase. When we get to the point where we model the stair in 3D, we'll see how it looks and see if we need a different proportion. I have a feeling that the stairs will need to span the entire length of one side of the planter. The last thing we need to add to the design are the drainage holes at the bottom of the planter. I decided to go with 9 small holes that are evenly spaced to form a grid. Now we're ready for the fun part, extruding each component. Starting with the base, I extrude the overall square with the drainage holes to create a 1/16 inch thick platform. Next, I extrude the planter wall so that the top is 3 inches. I repeat these steps for the remainder of the shapes and start refining the design based on how it looks. I'll speed this part up, but all I'm doing is trying different proportions between height, width, and lengths. I'm also modeling the stairs, which are an important part of this design. This is what the first model looks like, which is based on my sketch. The only missing component is the drainage pan that raises the planter so water can drain out of the bottom. I follow the same steps as before by drawing shapes to the sizes I sketched and extruding each one. Then, I use the Boolean union command to join them all together. This is what the two options look like. Personally, I like the stairs spanning end to end. The proportion seems more realistic than the original model. With the model done in Rhinoceros, we're ready to export the file as an STL file type to Prusa Slicer to generate the G-code for 3D printing this project. If you've never 3D printed a project before, I know that could sound like something out of this world, but trust me, it's the easiest part of this project. First, we need to import the 3D model to Slicer. Then, we need to select the print option for the project. For this one, I didn't want it to take a long time, so I'll go with a faster option. Now, we click Generate, and all the stats for the project, including total time to 3D print, is at the top left corner of the screen. The planter alone will take about 14 hours at a fast setting. A highly detailed setting would have taken 24 hours. Next, I bring my Prusa 3D printer to my workbench, save the G-code into an SD card, insert it into the 3D printer, and start the print. This part of the project is still amazing to me because it's the moment when you can see a machine translate something that was once an idea in my head and on paper to a physical object. Back when I was in architecture school, this was still considered a new technology and you needed to learn how to construct the printer, program it, and export G-code to operate it. Now, there are so many manufacturers who sell 3D printers as a complete package along with a slicing software and hundreds of filament types and colors. For this project, we're using a PLA filament and it's a galaxy gray color from Prusa. After confirming the print is coming together properly with the first few layers, I let it run overnight until it's complete. By the next morning, I check on the print to see if everything went as planned, which it did. You can see all the steps for the stairs and the entire planter is smooth all around. The drainage holes came out perfectly. Now we can lift the platform, bend it to pop the bottom of the planter off of the surface, print the drainage pan, and move to my workbench. I like to take a closer look at the print to see if there's anything that printed incorrectly and needs to be touched up. In this case, the planter and base looks great, so we can move on to the next step. I bring over a succulent plant that I've been growing indoors and start by loosening all the soil. I separate the succulents from the soil and place them in a pile on my workbench. Then, I pour all the dirt from the plastic container into the staircase planter and even it out so it's level at the top. I make small holes with my fingers and transfer each succulent into their new home. And this is how the architectural staircase planter came out. I love how the scale of the stairs against the succulents makes this product look like something from a science fiction movie where the plant is so much larger than the architecture around it. If you enjoyed this project, check out my other 3D printed craft videos and consider subscribing. I'll see you again next week.